Welcome everyone. My name is Léon from Berlo. I'm the Technical Director of buildingSMART International. At buildingSMART International, we're very passionate about openBIM and all of the abbreviations that come with it. But there's a lot of abbreviations and we use a special kind of lingo. So this video is to take you through all of these abbreviations and try to help you understand what they all mean and how they connect. So let's start with the basics. Usually a construction project starts with a good idea. Someone has a good idea and wants to convey that idea to someone else. And that's usually already where things get mixed up in translations. So we came up with a solution for that. The solution is drawings. For years, wonderful projects have been built using drawings. And at some point, these drawings got standardized. I think it's still a very underappreciated topic that every engineer knows that he needs to turn his head to the left to really read all of the drawings. Those standardized approaches made a huge, massive productivity gain in the construction industry. At some point, digitalization came in. We got digital and we got really even more effective in creating drawings. But digitalization evolved as well. And digital got smarter. From making drawings, we actually started to construct objects that were intelligent and had some kind of smartness in them inside a computer. And today we're at a phase where we have building information models with a lot of intelligence and a lot of data in there that help us automate tasks like clash detections and coordination between different stakeholders. And we're evolving. There's different kinds of simulations that can already be done. And this is really bringing a lot of productivity and effectiveness to the construction industry. So why are these data standards then so important? So first of all, we need to make sure that everyone has the same interpretation of the data. How do we call a piece of in a staircase? How do you call that flat slab? Is that a staircase or is that a slab? If you want to do cost estimations or scheduling, it's very important to make clear, concise agreements on those kind of things. Another reason to make standards is that you can actually automatically process things. So automatic clash detection, cost estimation, scheduling, CO2 emission calculation, automatic permitting, all of that relies on the fact that you have to have automatic processing and not manual checking. And to do automatic processing of the data, you actually also need to have the same interpretation of the different objects. And finally, it's about comparison and learning. If you have a lot of different projects that constantly use the same kind of definitions for the objects and the data, you can learn over time. You can see where the issues are that you can improve and further make some gains. So it's pretty clear why it makes sense to use one single data standard. But the kind of data standard you use is also important. You can be on an island and invite everyone to work with you on the same island, on the same data standard, but you're still on that island. And our fragmented construction industry has a lot of different islands. And due to the nature of our industry, you have to constantly switch islands and constantly work with other people and collaborate. So it's important not to settle on just any kind of data standard. It's important to have an open data standard. Why is open so important? So first of all, you need to be able to open your data. Having the ability to actually read the data set is crucially if you want to interpret the data from other stakeholders that you need to collaborate with. Second, instead of everyone being pressured on one island using one kind of data standard that they don't like, an open data standard is based on consensus and global international collaboration. So it's not one player who decides what kind of data structure you need to adhere to. It's a global international consensus standard that everyone can work with. And third, to me personally, the most important one, open data standards help you to control your own destiny. You're not forced to work on a certain island. You're not forced to work with a certain software tool. You can always switch different tools. You can always use cheaper ones. You can always use ones that are more effective, that fit your style of working and your niche better. So really taking control of your own digital destiny, really staying in control of your own data, having the ability to always access your data without any kind of dependence on a commercial software vendor, that's really important from an openBIM perspective. So let's look at some examples. So for us, the definition of openBIM is more than just one open data standard, but that one open data standard is our flagship. So we're talking here about the industry foundation classes, IFC. I'm sure many of you have heard about it and seen it. The trick is already in the name. It is the foundation of our industry. It doesn't hold everything. It doesn't hold every kind of object and a definition. It holds the foundational layer, the layer that everyone globally can agree on. And as you see, the license is a Creative Commons license that basically says, do whatever you want with this definition, as long as you don't change it. So this is the best of open. Everyone has access to it. It's freely available. It will always be there. Can't be deleted. Can't be retracted. Nobody can stop you from using it. But it's also a standard, and we want to keep it a standard. So that's why the license says you're not allowed to just change it on your own. You have to go through this consensus-driven process. IFC is obviously versioned. As you can see, there's a lot of collaboration going on from multiple people to try to get to consensus. It's very transparent. You can see who changed what and when, and it is openly available. When we look, for example, at an IFC stair, it's a massive amount of years of consensus, fine-tuning, really coming to different kind of definitions. What are the properties? How are you adding geometry to it? What is the placement? What kind of stairs are there? So it's a pretty well-defined standard. How big is it? Pretty big. There's hundreds of entities, thousands of properties, and there's always this question, how big should it be? Is it big enough? Since IFC is the foundational layer of our data agreements, it only consists of parts that we can globally find consensus on. So you would find one IFC wall with certain properties. You would find an IFC stair with different kinds of types. But searching for a plasterboard, for example, is something that is very specific to certain regions. So you will not be able to find that inside IFC. So there's always this question, how big should it be? And how can we still use all of these local and regional specific agreements together with this global agreement? To learn more about that, we have to dive a little bit deeper into the structure of IFC. So when you look at IFC, we have a layer that we call IFC product. An IFC product has geometry, it has a placement, it has an identifier, it has a name. It's very generic. There can be specific kinds of products, like a stair. An IFC stair has a certain definition, a semantic meaning. It has different kinds of additional properties linked to it that are specific for a stair. And this is all inside IFC because we can globally agree on what a stair is and how we're going to exchange it. But there's also very specific industrial stairways or very regional specific Danish flight of stairs that have a certain code that everyone in Denmark understands and knows. And then there can be even further details like company-specific stairways and company-specific staircases. This specialization is really where the combination of IFC and other standards comes in. So up to the global level, we can say we have an IFC kernel, we have different kinds of resources, you can connect geometry to it, spatial structures. This is all globally agreeable and defined in IFC, published as an ISO standard as well. We have some shared elements and we have some domain-specific parts in IFC. But the further you go, the more detailed you go, the more specific it gets. There's regional classification systems, domain-specific property sets, and even company-specific agreements. So we have this base layer called IFC, the foundation classes of our industry, and then on top of that we can amend it or extend it, however you want to call it, with these additional regional or domain-specific parts. So these further specializations work really well together with IFC, but how do you know where to find them? How do you make these connections? this is where we introduce the buildingSMART data dictionary, the bSDD. So within the bSDD, when you search for a stair, for example, you will find a lot of different terms. The first one that will pop up are obviously the ones from IFC. But if you select and filter, for example, on CCI construction, you will see very specific Danish definitions of stairs that have been around for years and have been used to standardize different automations in Denmark. So diving into the details, when we, for example, take a flight of stairs, you see this has a classification code LXSB, and really looking at how this is published inside the bSDD, inside our buildingSMART data dictionary, you see the relationships to IFC. So this code LXSB is actually related to an IFC stair, an IFC transport element, or an IFC stair flight. It has certain properties from IFC as well, but it also has its own owner, Moleo in this case. It has a version, it has a certain license, and to dive even further into the details, it has a unique identifier, a URI, and it also facilitates different ISO 12006 and 23386 features. So the buildingSMART data dictionary, the bSDD, is really the central point of our industry where different classification systems, different agreements, different specifications can link to IFC, but also can link to each other and publish their work in a central standardized way. So the bSDD is available on bsdd.buildingsmart.org. There's a lot of further explanations and videos if you want to dive further into the details. So what have we covered so far? We talked about why standards are so important. We talked about why it's so important to use open definitions and open standards. We looked at IFC, the foundation classes of our industry, and we looked at bSDD, how you can further amend these foundational definitions and link them to each other and publish them for everyone to use. What is more to come? Even more abbreviations, IDS, the information delivery specifications, BCF, our BIM collaboration format, and the different APIs that we publish under our openCDE umbrella term. So the best way to explain this is to just look at typical data flow in any kind of project. This can be construction of a building, it could be an infrastructure project. It always follows the same kind of steps. We start with setting the requirements, then data is being produced, then we do some kind of a check and validation of the data, and then we communicate the results and deliver them to different stakeholders. So let's start with the requirements. Typical requirements that we often see in the industry is, give me everything you have. Give me an LOD 350. I want IFC. I want stairs. These are obviously really bad examples. This is not how you do requirements if you care about interoperability. A better example could be, there should be at least one staircase in my model, and every stair must have a property called number of risers, and the value needs to be higher than 1. So how do you exchange these requirements? The way this is typically done these days is Excel, but there are really a lot of better ways. And this is where IDS, or information delivery specification, comes in. So we just saw the example of the Danish staircase with a certain code, which is a further specialization of an IFC stair. If you want to have that staircase, you would have the ability to take that identifier from the bSDD and put it into your IDS file. So IDS is an XML-based file format where you basically list whatever you need, and you can refer using these identifiers to the publication in the buildingSMART data dictionary. So you're basically saying, I want an IFC stair, but I want to further specialize it as this Danish CCI staircase. And I want to have a property number of risers, and I want to have some other stuff as well. If you put that in a computer interpretable way inside an IDS file, you can also generate a PDF from it that you can use as an addendum to your contract. So you would have a machine readable format, computer interpretable format that people can use to automatically check if the IFC data is valid, and you can generate contract text from it as well. So it's the best of both worlds. The nice thing of IDS is when you hand it over to a contractor or anyone who needs to deliver the data to you, they also have these identifiers to the bSDD where they can further dive into the details and understand what you mean. So instead of asking them for some kind of a weird code, you actually give an identifier in your IDS file where people can understand what you mean by that, read the definitions, and really understand better what kind of information you require. So IDS, our Information Delivery Specification, is a relatively new standard, but it has a high uptake and there's quite some support from the software vendors already. You can already use this today and it will only get better in the future. So back to our overview, we covered the requirements. Our Information Delivery Specification is the recommended way to define requirements. There's other ways as well. We have the abilities to support product data templates, PDTs, with our combination of IDS and bSDD. There's also other standards that work together with ours. So then, next step is to produce actual data. This is quite common in industry these days. You use a software tool to create a BIM data set, you export to IFC, and then we will get an IFC file that everyone has probably seen before. So for example, this IFC file of an actual stair, when we zoom into this, this is also again where this power of these identifiers, these URIs comes in. So zooming in here, you would see that the identifier to the bSDD is actually also located inside of the IFC file. So everyone who gets this file and wants to understand what this LXSB code actually means can just follow the link. You would end up at the bSDD again and you would see a full explanation of what the definition is of this Danish flight of stairs. So if there's anything you remember from this presentation, it is about how bSDD, IFC and IDS work together through these URIs. It's really this trifecta that coordinates all of the different parts and definitions is something that really brings added value to our industry. So then moving on, the next part obviously is to check your data. Is the data according to the requirements? Is the data according to a predefined set of rules that you created? This is a very popular thing that people are doing now with IFC files. It's not just class detection, it's information quality and information consistency that can be checked. And then again, how are you going to share the results of these checks? There's a lot of different tools out there that can be used, but the results needs to be processed by your project partners that not necessarily have these tools. So instead of using email where you would say, this stair needs to be fixed, you know, the second one from the left on the third floor, the red one, and you put that over email, that's basically asking for a disaster. So this is where BIM collaboration format, BCF, comes in, where you have a structured way, again, an XML format, where you can really say, this is the topic I want to have discussed. We're talking about these specific objects with these identifiers. This is the camera view, how you can best look at the problem. This is the priority, I'm assigning it to these kind of people. So this is the power of BCF, the BIM collaboration format, how that can help in really communicating the different issues after a check. So we would have IDS now for defining requirements, IFC to share the data, and BCF to communicate the checks. How can openBIM standards help to actually deliver this data to your project partners? How can you effectively deliver an IFC file? How can you effectively deliver issues structured as a BCF? And this is where one of our new standards come in, the openCDE portfolio of APIs. This is relatively new, but also already available in some leading software tools. These are quite a technical format. It is quite a technical standard that defines an interface. It's quite different from the data standards that we also have. But this is a very nice example where the use case of downloading a file from a CDE has 6 steps. You open a browser, you log in, you find your documents, you download the files, you save them to a folder, and then you open files. This can be much more effective. So the openCDE Documents API standard is here to just cut out and reduce the number of steps. So what we want to do is directly log into the CDE and open the files inside of our browser. There's a couple of really good examples where from Solibri, for example, you can open a file directly from Aconex without having to leave Solibri and directly having your IFC files. Also pushing back BCF topics after you did a check in Solibri pushing those back into the CDE as well without even leaving your Solibri software tool. This is relatively new, but we also see high efficiency gains in openBIM workflows thanks to this standard. So, wrapping up, we've seen quite some logos. We've talked about this openBIM concept that basically consists of different standards combined in a certain workflow. We've walked through the different kind of steps and how things relate to each other in the standards and in the workflow. There is more, there is a lot more. I can talk for hours about this. We also have a validation service to check if your IFC file is actually compiled according to the specification and the ISO standards. We have a translation system where we ask the community and our chapters to help define, to help translate the different terms of IFC from English into local languages. We have a use case management system or use case marketplace where you can publish best practices and use cases, and you can also find best practices and use cases to get a flying start and hit the ground running on specific tasks that you need to perform. And there is even more. So the openBIM concept, which consists of different kinds of standards, it is further facilitated by our services like the validation service, the use case management service, and the buildingSMART data dictionary. And we also have different kinds of certification. Our professional certification program, which is focused on education of professionals, and our software certification program, which helps software vendors more consistently implement the different standards inside their tools. All of this combined is what we call the openBIM workflow. And I really invite all of you to try it out. It works. It might be a little bit scary in the beginning, but it's really effective and it will really help you do your job better. So, as you see, the openBIM workflow actually consists of multiple different standards and tools and services that we offer. It's really easy to use, and I invite all of you to actually try it. I hope you learned something new. Just as a short wrap-up to put all of the logos on one slide, we have the openBIM workflow as a concept. It consists of multiple different standards like IDS, IFC, BCF, and the Documents API, the full set of openCDE APIs. We have additional services to help you use the standards in a better and more efficient way. Validation service, our use case management service, and the buildingSMART data dictionary. And we also have certification programs. Our professional certification program really helps educate professionals to work in a more effective way with all of these tools and services and standards. And we have the software certification program, which helps software to implement the standards in a more consistent way to also help the industry to be more effective. I hope you learned something. If you have any questions, don't hesitate to reach out. We're here to help. We're really happy to help you move forward on this.